Well, good morning, fifth graders. We're starting, as you can see here, Math 1.4, pages 18, 19, and 20 in your math workbook here. So we're just working with some decimals again. They're giving you some different ways to look at it, some different problems. It says here, Joe picked a seed from a flower. The seed has a mass of 0.245 gram, or of a gram. What are some of the different ways you can represent 0.245? Well, standard form, which is really what that is right there. It's the number written out. Expanded form, you've seen that. And number name, which is just handwriting it out. Okay. And then for a decimal, just like you can for a whole number. So in other words, decimals, you can do the same thing. You can write them in standard form, expanded form, or handwritten out in what do they call it? Name form, I think it is. Okay, so let's look at this example here. Here is 0.245. That's standard form. Even says it right there, and it points out that the 5 is in the thousandths. Notice that THS ending in the thousandths place, and its value is 0.005. If you weren't going to worry about any of the other digits, the 5 by itself would be worth 0.005. Here it is in expanded form. It's 2 times 1/10. Well, that represents that 2 right there. And then 4 times 1/100th, that represents the 4. And of course the 5 times 1 over 1,000 represents the 5. And then the number name, it's 245 thousandths. The THS ending lets you know that we're talking about decimals here. So how big is a gram? I mean, how much is a gram? We're talking about a fraction of a gram, all right? In fact, if I was to ask you to convert that into a fraction, you would know to write, hopefully by now, 245 over 1,000, okay? That would be representing 0.245 in fraction form. But let's look at what do grams look like? What are some examples of some grams here? So take a look at this here, a regular size paper clip that weighs 1 gram. A dollar bill is also 1 gram. And a US nickel weighs 5 grams. And so imagine if we were to take that nickel and we were to reduce that to 1/1000th of a gram. I'd have to draw a bunch of little tiny lines dividing this nickel up. And they'd be so small you could probably barely see them. Maybe under a microscope you could. But just one tiny little sliver of that nickel might be 1,000th of a gram. And let's see here. Let's move this up a little bit. I'm going to work in layer 1 here. And that's funny how those lines came out. Okay, convince me. It says how many hundredths, THS ending, are in 1/10? How many hundredths are in 1/10? That would be 10. There are 10 hundredths in 1/10. And then I'd ask how many thousandths are in 1/100th. And again, it would be 10 thousandths in 1/100th. Okay. Remember, when we have a place value chart, And I'm just going to use x's in places of numbers. The numbers are really kind of irrelevant here. And here's my decimal. And there's 3 more. Remember that the difference between these guys, assuming they're all the same number, if they're all 2s or they're all 9s or they're all 7s, there's a difference of 10 depending on the direction you're going. If you're going in this way, okay, so this one here is 10 times larger than that one. And this one here is 10 times larger than that one. And this number here is 10 times larger than that one. 10 times each way. Now, if we were going across the top here, this number here is 10 times smaller than this one. This number here is 10 times smaller than the one to its left. And what if we went from here to here? That would be, since we're moving 2 places, that's going to be 100 times smaller. This one is 100 times smaller than this one. All right. So let's look at what they want you guys to do here. Another example. It says, name the same amount. What are 2 other decimals equivalent to 1.4? Okay, this is something that we haven't talked about yet. And it says 1.4 is the same as 1.40. It also says 1.4 is the same as 1.400. And what I want you guys to understand here is that when you add zeros, it doesn't change the value. So for example, if I had 2.6, that's the same value as 2.60. It's also the same value as 2.600 and 000. And I can keep adding zeros and they would still be equivalent. Adding all these zeros does not change the value. Now, if I was to change one of these digits here, if I was even to change just the last one and make that into a 1, then they're no longer equal. But as long as you're just adding zeros, it doesn't change the value. Okay? And if we were to put it on a place value chart, okay, here's my place value chart. Here's 2.6, and here's the decimal. Well, here's this one, and here's this one, 2.6. See, it doesn't change the value if I add all these zeros. It doesn't matter. Okay? All right. So, let me erase this really quick here. Okay, guided practice. It says the number 3.453 has 2 3s. Why does each 3 have a different value? Well, they fall on a different place or location on a place value chart. I think that's pretty obvious here. Okay. In 2 and 3, it says write each number in standard form. Okay, so let's look at number 2 here. 4 times 100, that's going to be 400 something. 7 times 10, that's going to be 70. 6 times 1, that's going to be 6. Plus 6 times 1/10. What do you think that's going to be? 6. Plus 3 times 1/100th. 3. Plus 7 times 1/1000th. 7. So 4.7, I'm sorry, 476 0.637. That was kind of a hard one, but I think you guys could do that now if I gave you your own. Maybe I will. All right, number 3, 4 and 68 thousandths. 4 and 68 thousandths. We're talking about small numbers here. All right, 68 thousandths. 0, 6, 8. That 8 needs to go all the way to the thousandths place. I'll give you some more like that for you guys to practice on. Maybe we'll talk about those tomorrow. Let's move up a little bit here. What do we got here? Write each number in standard form. I think you guys could do those. I'll do one of them. How about I'll do number 6. 9 and 20 hundredths. So 9, and there's the decimal, and 20 hundredths. So that'd be 9 and 20 hundredths. We need to go to the hundredths place. Okay. Now, let me point out something to you. If you had just put 9.2, that also would have been correct. Either one of those. Remember, we can add all the zeros we want. It's not going to change the value. Okay? 9.2. Okay. You can try 4 and 5 on your own. Let's see here. 7 through 10, write 2 decimals that are equivalent to the given decimal. This is easy. This is easy. All you guys have to do is add some zeros. So it says write 2 decimals. I'll look at number 9 here. So we have 9.50. How about 9.500? That's the same. How about 9.5000? All right. You can do the rest. Next page. Okay. The annual fundraising goal of a charity is $100,000, and they've raised $63,482. How much more money is needed to reach the goal? Well, this is how much more they need. So this looks like a subtraction problem. You're going to subtract one from the other. You guys can do that. Number 12, Santiago, is that what it is? Has a rope that measures 205.95 centimeters. Write this number in expanded form. Oh, that's easy. I'll start it off. How about 2 times 100 in parentheses plus, and I'll just put it in there so you're not confused. Normally you would actually leave it out. So the first number is a 2. What's the second number? A 0. So it'd be 0 times 10. But again, normally you wouldn't do that. I don't want you guys to be confused because there's nothing in the tenths place. And then plus 5 times what? 5 times 1. Plus, now we're not done yet. We've got to do the 0.95. It's going to be 9 times 1/10. Plus, and then I'm going to let you do the last one. 5 times something. I'll let you figure that one out for yourself. Number 13, how can you tell that 7.630 and 7.63 are equivalent decimals? Well, how can you tell? Well, I would say, there's a lot of different ways you can answer that one. Let's see, the 7, 6, and 3 are at the same place value. And adding zeros doesn't change the value. Number 14, in Justin's school, 820.825 of students participate in a sport. If there are 1,000 students in his school, how many participate in a sport? So 825 over 1,000. Okay. So what they're saying is 825 out of 1,000. 825 students. Remember, you got to label these numbers. Sometimes I forget that myself. 825 students. Number 15 here. Let's see. Maria incorrectly placed the decimal point when she wrote 0.65 inch for the width of her tablet computer. What's the correct decimal number for the width? Oh, okay, so I guess we got to count these here. 0.65 of an inch. Okay, so it looks like this is the beginning here, so that would be 0. This would be 1 inch. This would be 2 inches. I'm assuming this here. Here's 3 inches. Here's 4. Here's 5. Here's 6. So it looks like it's 6. And is she talking about just the screen or the whole width? Looks like the whole width. So each one of these little marks here would be a half. So there's a half mark, there's a half mark. Those little green dots are the half marks, if you could see it. So it looks like it's going to be 6.5. So it's 6.5. So what is the correct decimal number for the width? I guess it would be 6.5 what? You got to label it, remember, inches. Number 16, 3 boys cut out hundredths decimal models. So each one of these squares here have 100 little tiny squares. Derek does not shade any of his models. Ari shades half of one model. Wesley shades 2 models and 1/10 of another model. What decimal represents the amount each boy shades? So, all right, I'm going to do the first one. Derek, he does not shade any of his models. So what decimal would that be? So I'm going to put down Derek. It'd be, I guess, 0.0. And then Ari, if I'm saying that not right, Ari shades half of one model. What decimal represents the amount each boy shades? Well, I don't know if they're talking about all 3 or just 1, so let's keep it simple. What's half of 1? It'd be 0.5. How do I know that 0.5 is half of 1? All right, well, what's 0.5 plus 0.5? If I added those together, what's 5 and 5? It's 10. Put down the 0, carry the 1. 1.0. And then Wesley shades 2 and 1/10 of another model. Okay. Well, I'm not sure I did the second one correctly, but I'm not worried about it. I think you guys understood what I was saying here. So 2 and then 1/10. So one little area here. And these are shaded. So it'd be 2 point what? 1. That'd be 1/10. All right. For 17, it says the last one, find 2 decimals that are equivalent to 4 times 10 plus 7 times 100. Write the decimals in the box. I guess they're talking about this box here. 2 decimals. So I don't know. You have to circle them or what? I'm not sure. It's not very clear to me. Maybe you just write. Oh, okay. So I think just look at these here and see which ones are equivalent to what they've given us here. 4 times 10 plus 7 times 100. So you maybe write that in standard form and then see if you could spot it here. Okay, that's it. And we will grade this. This is tomorrow's work, so this would be Thursday. So we would grade this Friday morning. Okay, I'm going to end this. Talk to you guys soon.